All right, for the Chapter 6 review, we do have some people in here live with us, so you might hear them ask some questions here and there. 1, 2, and 3. So this problem's pretty much the same for all three of them. The only thing that's different is the number of sides. So what we're using here is S equals 180 times n minus 2. So for each of these, a pentagon, we're basically just saying n equals 5. A nonagon, n equals 9. And here they're just telling us n equals 15. So you're just plugging in for n. We'll do the first one. I'm not going to do 2 and 3 though. So this would be S equals 180 times 5 minus 2, which is just 180 times 3, which is 540. Just be careful you understand that they're asking find the measures, the sum of the measures. They might ask you what is just one of them. They might ask you what's the sum of all of them. The next set, now they're giving us the sum. So when we look at that formula up above, S equals 180 times n minus 2. Now they're giving us S. Now there's two ways algebraically to solve this. The way I'm going to solve it might not be the way that you initially thought about solving it. So 900 equals 180 times n minus 2. Instead of distributing that 180, you're just going to make more of a mess. Remember, we're trying to get n by itself. N is all by itself. If we distribute the 180, you're just bringing something onto that n. So let's just get rid of that 180 from the beginning. That's 5. And now those parentheses don't need to be there anymore. So it's a 7-sided polygon. And nothing changes for 5 and 6. Just a little follow-up on 1, 2, and 3. If it's a regular polygon and they ask you for just one of the interior angles, then you would divide this by the number of sides. All right, so I'll do either 7 or 8, and then I'll do 9 or 10. I won't do all 4 here because it's a little redundant. Now, these are not regular polygons, okay, but they still do follow the same formula we just used. So we have 1, 2, 3, 4, 5. We have 6 sides. So that's 720. So these are all going to add up to 720. So if we're looking for x, we're basically going to peel everything away from that 720. So 720, I'm going to take away the 105. I'm going to take away the 142. I'm going to take away the 140. That's a bad 140. I'm going to take away the 124. And I'm going to take away the 88. And that's going to leave us with 121. Number 8's done the same way. It just won't equal 720. You have to figure out what the interior angles should add up to equal. Now, for 9 and 10, we're dealing with exterior angles, and it doesn't matter how many sides you have, it'll always add up to 360. So x plus 2x plus 75 plus 93 will equal 360. Subtract that 93 and that 75 from both sides. We get 3x equals 192. So x is 64. And it says find the value of x. It doesn't tell me to find the other exterior angles. So x equals 64 is fine there. All right, find the value of the variables in the parallelogram. So we have a parallelogram here. We know that the opposite sides are congruent. So x plus 2 is going to equal 4. So x equals 2. And we know that 12 is going to equal y minus 5. So y equals 17. Number 12. So now we have something to deal with sides. So that's going to build off just what we did earlier on the previous problem. So x equals 4. And then opposite angles are also congruent. So 4 and 116. All right, number 13. Opposite sides should be congruent there. So 25 equals 8g minus 3. 28 equals 8g. Divide both sides by 8. We get g equals 3.5. Now, for the angles, we do not have opposite angles. These angles should be supplementary. So 72 plus f plus 30 equals 180. So f equals 78. All right, the diagonals here are going to bisect each other. So 9 is going to equal 2n minus 1. 3m is going to equal m plus 8. 10 equals 2n. n equals 5. On the other side, we have 2m equals 8. So m equals 4. All right, so that's basically using the properties of the parallelogram. Opposite sides are congruent. Diagonals bisect each other. Opposite angles are congruent. And remember, these are like same side interior angles here. So adjacent angles. All right, number 15. So PQ, QR, and RS. It's saying that those three segments are congruent. And since we have parallel lines, that means this transversal is also creating congruent segments. So if this is 3.3, that means XV is also 3.3. And that means WV, which is three 3.3s, is 9.9. Decide whether the parallelogram is a rectangle, a rhombus, or a square. Remember, a rhombus has 4 congruent sides. Check, it has that. A rectangle has 4 right angles, which means we only need 1. Okay, if that's 90, opposite angles are congruent. And then these are supplementary. So if one's 90, they're all 90, which means it's both a rhombus and a rectangle, which makes it a square. "17. Find the measures of the numbered angles in the rhombus." So they're telling us it's a rhombus. Diagonal are perpendicular. So that means the measure of angle 2 is 90 degrees. Remember, the diagonals also bisect each opposite angle. So this is also 64. Also, it's a parallelogram. So those are alternate interior angles. So the measure of angle 3 is also 64 degrees. And then theorem 311 says the triangle has to add up to 180. So the measure of angle 4, which is going to also equal the measure of angle 1, is going to be 180 minus 90, which is 90, minus 60, which is 30, minus another 4 is 26 degrees. All right, the diagonals of the rhombus PQRS intersect at T, given that the measure of angle RPS is 30 and RT is 6, find the indicated measures. So the measure of QPR, so basically it's that angle, that is also going to be 30. QTP is going to be 90 because diagonals are perpendicular. RP will be 12 because the diagonals bisect each other. So 2 times 6 is 12. And then the measure of QRS is going to be 2 30s together. So 60 degrees. All right, the diagonals of rectangle. So always pay attention to what classification these parallelograms are. So we're just dealing with a rhombus. Now we have a rectangle. That's basically going to open up the properties that we are allowed to use. So remember, for rectangles, we have 90-degree angles. The diagonals are congruent. It's also a parallelogram. So diagonals bisect each other. Opposite sides are congruent. Opposite sides are parallel. So given that, YXV is 50 and XZ is 12. What is the measure of WXZ? So since it's a rectangle, we have 90-degree angles at the vertices. So X has to be 90. So that means this must be 90 minus 50, which is 40 degrees. WPX. Now, this is not a rhombus, so that does not mean that the diagonals are 90 degrees. But we do know that the diagonals are congruent and they bisect each other. So this is going to be congruent to this, which means that's an isosceles triangle. So that means those are both 40. And they have to add up to 180. So that is minus 40. Oops. So it's 100 degrees. All right, PY. Well, we know XZ is 12. That means WY equals XZ, which equals 12. So PY equals half of WY, which equals 6. And we already answered. I actually think they should have flip-flopped these questions. 12. I would say 23 here is probably the hardest one to straighten out because sometimes we get caught in that idea that these corners are bisected. So that's 50 and 50. Remember, it's a rectangle, so those should be 90 degrees. Okay, we're not talking about a rhombus there. Whoops. And all these answers are already located in the Schoology folder, but there's no work shown. It's just raw answers, just an answer key. All right, the diagonals of square. So now we get those properties from rhombus and rectangle all in one. They intersect at H, given that EH is 5, the indicated measurements. So GHF, it's a rhombus, so they're perpendicular, so that's going to be 90 degrees. DGH, it's a rectangle, so DGF is 90. And since those vertices are bisected, DGH will be 45. All right, HF is also going to be 5 because it's a rectangle, diagonals are congruent, and they bisect each other because it's a parallelogram. DE, so DE requires just a little bit more critical thinking here. Two ways to look at it. This is also 5, and that's a 90-degree angle, so that's a right triangle. So the Pythagorean theorem says that that is C. So 5 squared plus 5 squared equals C squared. So C squared equals 50. So C equals the square root of 50. So DE equals the square root of 50, which is about 7.07. You could also do that by looking at the big triangle and say if this is A and this is B, it's a square, so they're actually the same thing. So 5 and 5. Let's say this is X and X because it's a square. That means X squared plus X squared equals 10 squared. So that's 2x squared equals 100. So x squared equals 50. And we're back in the same boat. X equals the square root of 50. Two options there. I'm just going to do one of these next four because they're all based off of the same theorem. That the mid segment, so 12, is going to equal half the sum of the two bases. I would say the hardest part of this algebraic process is you are going to distribute in 1/2. So it's not always the most pleasant thing. But it's the same process. All right, 34, we have an isosceles trapezoid, which means that the base angles that are attached to the same base are congruent. So that means if this is 65, that means this is 65. And then these are supplementary. So this is 180 minus 65, which is 115, which means that's 115. Also, they should all add up to 360 because it's a quadrilateral. So the sum of the interior angles should add up to 360. So there's really kind of a separate way around that as well. All right, for a kite here, we have, again, it's a quadrilateral, so they should all add up to 180. Find the measure of angle K. It's 88 degrees. Basically, we have two isosceles triangles. So these base angles are the same, and these base angles are the same. So that means the sum of these two has to be the sum of these two. So they both have to be 88. Angle K. We know they all add up to 360, and these are going to be the same thing. So 360 equals 60 plus 50 plus 2x. So 250 equals 2x. So x equals 125 degrees. So the measure of angle K is 125 degrees. And the last one. Find the missing measures in the kite. One is 90. That means the measure of angle 2 is going to be 90 minus 52. I'm sorry. 180 minus 90, which is 90 minus 52. So technically I would have been all right there. And that's 38 degrees. Which means that the measure of angle 3 is 38 degrees because we created two congruent triangles right there. Two congruent triangles. CPCTC tells us that 3 is 52.